important. You said it's the case that in paper, so I wonder what I said when I went through it. But anyways, let's go through it. It says here. So I mean, like one or the other, because this is 11.2, it kind of goes with 11.1.
Yeah.
So okay, there's no equation given, but they gave us this information, and they said we should use the graph to answer the following question. So you say you managed to answer 11.2.1. 11.2.2 says if g of x is equal to negative f of x, write down the coordinates of the local minimum point of g. So you can see this is just a 2-mark question. The reason why it's a 2-mark question is because we are not supposed to overthink it. You see, we're supposed to make use of specifically what has been given to us, especially here, because the idea is, you see here, right? If they're talking about a turning point of negative f of x is the graph of g. So whatever f of x is, right, based on this information, we want to be able to think to ourselves, what does the image of f of x look like? Because the moment we know what the image of f of x looks like, the image of g of x, sorry. No, not the image of f of x, because g of x is f of x when you multiply it by a negative. So g of x becomes the new graph. So before we can see or imagine what the new graph looks like, we need to know what the original one looks like, and then we just need to flip it over. Because let's see here, based on this information,
is that what? Oh, so we were just meant to flip the f of x graph over the y-axis or the x-axis?
We're supposed to flip it over the x-axis. The reason is, remember, this is f of x, remember, stands for y. So if you have a graph, right, or rather if you have a Cartesian plane, let's have a Cartesian plane. Let's draw a parabola.
Now, okay.
Yeah, you have a parabola. This is the x-axis, this is the y-axis. So if this parabola, let's say it's h of x, right? This is h of x. You can already see that this is where you have positive y values, and this is where you have negative y values. Now, if you have negative h of x, remember h of x stands for y. So if you now have negative h of x, it means that you're flipping over the y values, meaning that the y values that were positive will become negative, and the ones that were negative will become positive. So if this one is h of x, negative h of x, what will swap around is the y values. So where you have these negative ones, you will start to have these positive ones. And then where you have these positive ones, you'll start to have these negative ones. Where you have these positive ones, you'll start to have these negative ones, you see. So this one up here is g of x, the one down here is negative. This one is h of x, this is negative h of x, you see. So that's the idea here. Right. It's just a graph of f. Whatever it looks like, we're just flipping it over the x-axis. So meaning if it, for example, we're just using an example right now. If your f of x looks like this, we don't know yet, but if this is a maximum turning point and this is like a minimum turning point, technically speaking, when you flip it over, you are just going to have the maximum becomes the minimum becomes the maximum, you see, of which the only thing that changes is the y value. So whatever y value is here, it's going to be the reflected version down there, but the x values will be the same. Same here, you see, the x values will be the same, but then the only thing that changes is the y value, because whatever y value is down here, you're just going to reflect it up there. So we need to find out what kind of an image will this draw. It's this information here. So to do that, we have to make use of almost everything, really, because firstly, they're telling us things like, let's see, so we have a Cartesian plane, technically. In this Cartesian plane, our information is telling us that where x is a 0, the y value is a 3. So that's technically the y-intercept, you see. So somewhere here, where the y value is a 3, while x is a 0, that's a y-intercept based on this thing. And then here, this is technically an x-intercept, because where the x value is a -3, you have a y value of a 0. You see, so that is this point over here. Well, let's maybe color code it, just for the vibes. So there's green here. It's this here. And then this is referring to the first derivative. Now remember what we mentioned in our previous question here when we were talking about, you know, the first derivative and everything. We mentioned that the first derivative is always telling us about gradient. So this is saying that all these gradients, this is saying that in the gradient equation, if your x is -2, the y value, the gradient is a 0. This is saying if the x value is a 1, the gradient is a 0, because you're dealing with the gradient equation. They just gave you two sets of information in one line, you see. And these are technically our turning points, because this is telling us that if the x value is a -2, the gradient is a 0. So wherever a gradient is a 0, that's a turning point, you see. So we already know that where x is like a -2, somewhere here we have a turning point. And then where x is a 1, which is like somewhere there, we also have another turning point, you see, like that. So now we have to be strategic, you know, because apart from us even being strategic, I mean, they've given us a whole lot of other information here. They've given us a coordinate and another coordinate. Fortunately, if you look at it nicely, you see here, this is the same x values as the ones above. But then you can see that this is into the equation of f directly, of which we know that in the equation of f, now you're dealing with coordinates, meaning if you throw that same x value, you're getting a corresponding y value. If you throw that same x value, which is like a 1, that would give you a gradient of 0 in the gradient equation. A 1 in the normal equation of f would give you a y value of 1, of which those are now the coordinates of your turning points. So meaning at -2, the y value is like a 5, like somewhere up there. And then where x is a +1, the y value is a +1 as well. So that's like somewhere over there. Now the fortunate thing is if your graph turns here and your graph turns there as well, but it also cuts the x-axis here. I mean, logically speaking, it has to look like this. It has to go up, turn there, cut your y-axis at 3, and then turn here as well, you see. So this is what the graph of f of x looks like. We literally just joined our dots, you know, turning point, x-intercept, y-intercept. So if this is an x-intercept and this is a y-intercept, I mean, like the graph has to touch both of them, you see. And knowing the shape of a cubic function, it has to be in a specific way. You know, we cannot just do things randomly. So does this shape make sense?
Yes, it does. Makes sense more than what I had on the page.
Ooh, okay. Well, I guess let's let bygones be bygones for now. So with this image, right, all that has happened is if they're talking about g of x being negative f of x, what they mean is, let me see here, let me just make sure this is gonna come out nicely. Let's use a peach, yeah. So what they mean is, right, if the graph of g is f of x flipped over, all you're gonna have is, in your Cartesian plane, right, you already know that, okay, fine, you can just use this image nicely. I mean, let me not even make it in a different sketch because it's a bit harder. When you have it here, it's easier because now instead of going up first, you're just gonna go down. And then somewhere here, it's gonna turn, right? And you can see if your y-intercept is at 3, it's gonna be at -3 as the reflection. You know, it's just logical that way. Because remember, they are just reflections of each other. So if it's 3 units up there, it would need to be 3 units down here. I mean, my sketch is not necessarily to scale, but you know, we can fix that. We can fix that a bit. Let's do this. It's gonna go down and it's gonna turn somewhere. Now, yeah, I need to make it a bit to scale some more. Otherwise it's gonna be a disaster. So all we need to do is to work based on the line of reflection. Because if you look nicely, right, the line of reflection is the x-axis. So meaning everything that's important, always just use the x-axis as a way to help you. So the distance here, it's 5, right? It should be 5 going downwards as well. So we can put that point there. The distance here is like a 3. So it should be 3 going downwards. So that's going to be somewhere there. And then here, the distance here is a 1. Remember, it's like 1 up. We saw here it was 1 coordinate 1. So meaning in the other direction, it also has to be 1 down. So it's going to be like a turning point somewhere there. So meaning your graph, I mean, like without making it too fantastic, it's gonna look something like this. Now goes down like that. Whereas here it's going up like that. And you can see this, it's somewhat a mirror image of itself. Because where you have an arrow down here, you have an arrow up there. You have a turning point here, turning point there. Y-intercept here, y-intercept there. Turning point, point of intersection with the x-axis in the same place. And then arrow going up, arrow going down. So this is what negative f of x is. Of which negative f of x, as they said, it is just going to be the graph of g of x. You see, this is g of x.
Sure.
Yeah. So in the question now, they said, write down the coordinate of the local minimum. So we already stated that, I mean, the local minimum is going to be the local maximum of the reflection. So you can see here in the original graph, this one is the local minimum. This one is the local maximum. So the maximum now is going to become the local minimum for the other graph. The local minimum is going to become the local maximum for the reflection. So if they want us to get the local minimum of G, we just have to use this coordinate to help us, because we already know that based on the information that we were dealing with, the X value here was a -2, the Y value was a 5. So its reflection, we can already see it's the same X value, still a -2. But then if it's 5 units up going this way, it would need to be 5 units down going that other way. So this is going to be the coordinate of the local minimum.
Thank you. Thank you.
You are welcome.
And then,
you are welcome.
And then taking it back to question 7.
Let me just stop this one. Is question 7 in the same paper?
Yeah.